So, all right, conditional probability. Now, how's this different from the theoretical and experimental that we've been doing? So, we're going to have two events that are occurring simultaneously. So, what happens is the probability that of this certain event occurring, knowing that another event has already occurred. So I know this happened, so now with that happening, what's the odds of this occurring? So what that would look like if we were seeing a problem in a math book, let's say, instead of just having P and then having like A or B or something, it would look like this. And here's how you would have this read to, or maybe written out in a story problem. It would be read as the probability of B given A. And that word given is the big one on here, because that's telling me what already happened, which kind of narrows down the possibilities that I have. So when I look at my formula, it's going to be the probability of both events, A and B, and again, we'll be much more specific in a minute with these, over the probability of just the first event, the one that we know about. You're like, okay, Harty, enough of all this gibberish with A and B. Get me something that I can actually wrap my head around. Okay, so number 2, let's say. A number from 1 to 100 is randomly selected. What is the probability that it's a perfect square given that it's an odd number? Okay, there's that word given. Whatever is written after that. So I'm going to try to do some underlining in colors here. Okay. Given that it's an odd number. So that's always going to be what goes in the denominator of my fraction. That's my event A, this odd number. So then, okay, so what's this B then? What's the probability that it's a perfect square? But notice up top, it's the probability of A and B. So the probability of it being odd and a perfect square. And that's going to be the difference with these. Whatever's after given goes on the bottom. And then that plus the probability that I'm looking for goes on top. So let's think about this for a second. If I have 100 numbers, how many of them are going to be odd? 50. Half of them will be odd, half of them will be even. So we know the number on the bottom of the fraction will be 50. Now the next part gets a little more interesting. Odd and a perfect square. So whether it's pulling out my multiplication chart, pulling out my factoring one maybe because we got the perfect squares on there, or maybe it even becomes writing it out like this. Even though we've spoken several times about the need to know our perfect squares up through 10, here's another reason why. But remember, it's not just that it's a perfect square, it's that it's a perfect square and it's odd. So I go find the ones that cover both. 1, 2, 3, 4, 5 of them. And then, as always, if I can reduce my fraction with some math enter, or just knowing that both those are divisible by 5, I do that. Okay, so I may have to do a little bit of calculating, but the biggest part is getting this part set up at the beginning. We're going to get lots of opportunities with this today. But if after I do one, you don't get why I did something, like, wait a minute, just kind of wave at me, and I'll try and figure out a way to say it a different way. So number 3, we got a whole paragraph. 62 people taking a yoga class, 48 people that take spinning class. 15 people that take yoga also take spinning. If a person from these groups is selected at random, okay, here we go. Find the probability that he or she is taking yoga class if you know, that's just another way of saying given, if you know they take spinning class. So again, the part that I know always goes in the denominator, always goes on the bottom. And then my numerator is the two events that are going together. So the probability of being in spinning and, let's see what else is going on. Find the probability he or she takes yoga class. So spinning and yoga. So just notice how we keep putting them together this way. Now let's see if I can get this straight from the problem. I'm going to have to do a little thinking. All right. 48 people take spinning class. Okay, we got that part. That was cool. 15 people that take yoga also take spinning. There's my yoga spinning, my 15. Well, I like it when it comes out nice like that. And I just reduce the fraction, and they're both divisible by 3. Now, is it the worst thing ever if you leave it like this? No. But again, we always want to get that reduction down there as best we can. But the whole thing keeps coming back to this. So one more of those, and then we'll kind of talk about it in a little different of a form. Of the 30 students in Mrs. Smith's math class, 13 are athletes, 9 are in band. 3 of the athletes are also in band. If one student is chosen at random, find the probability that this student is in band if it is known, given, that they are not an athlete. Ooh, okay. So probability not an athlete. Okay, that's my denominator. Now let's work it back because we know up top not athlete will be part of this. But what else are we looking for? Find the probability the student is in band. Not athlete, band. That puts both together. All right. Let's see here. Of the 30 students in Mrs. Smith's class, 13 are athletes and 9 are in band. 3 of the athletes are also in band. Doesn't say anything about not being an athlete. But can I get that information if it's not given to me directly? The answer is yes. Because let's think about this for a minute. If 13 are athletes, and there's 30 students in the class, call them NAs, non-athletes. Because if you're not in the 13, you're in the other group. So I know that there are 17 non-athletes in the class. What about band members? Let's see, 9 are in the band, but wait a minute. Does that tell me about the not athlete part? 3 of the athletes are also in the band. Okay, so if I have 9 band members, but 3 of the band members are athletes, and that's not what I want. I want the non-athletes. I have 6 band members left that aren't athletes. And sometimes that's as far as I'm going to get as far as reducing goes. But did you notice there, the numbers didn't directly tell me everything. So I had to do a little more digging, I had to do a little more thinking before I could actually get to the value that I was looking for. Okay. So sometimes with conditional, I've got to go in and dig it from a paragraph, from a couple of sentences. Other times, I'm going to get some information from a table, depending on some categories. These are called two-way tables. So here, the table shows the results of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. Find each probability. like we did before when we had the charts, I'm going to total up all of my rows and columns because I never know which bits and pieces I'm going to need. So, now I look at the probability and I'm like, wait a minute. What's this? P prefer football dash girl. Roll back up here for a second. Probability of event B slash event A. Come back down a minute. So here's what this is saying. What's the probability a girl, because remember, when we're doing this, that's event B and event A, and A is the one that goes in the bottom. So the one after the slash is the one that will go on the bottom. And then the one on top is both. Girl prefers football. So it's the same thing we were doing up in 2, 3, and 4. It's just in a different format. So, girls. 22 of them. Girls that prefer football. Okay, so if I was actually looking to read this, it would be, hey, what's the probability of finding a girl who prefers football given that, it's a girl? Seems kind of repetitive, but that's how these work. So, in letter B then, what's going to go on the bottom of my fraction? Well, what label? Your little hockey. So whatever that second thing is, the thing after the slash, that's my bottom. And then on top is the two together. And I let my chart give me the numbers. Yeah. Because when I'm doing these, it's whatever is after the slash mark is in my A value. And that can be the thing that's tricky because you're like, girl, and then you see the next one, you're like, oh, boy has to go on the bottom. I mean, that makes sense. But we've always got to watch for that thing that's afterwards. So then hockey, the hockey part. Then on top, I'm looking for hockey and boy. And then reduce the fraction as much as I can. So that's going to be my biggest key with these. Making sure that I'm really watching to make sure the second part, my A, goes on the bottom, and then I don't get sucked in to some of these areas sometimes. And I'll try not to kill you with doing all of these on the back, but I want to make sure we've really nailed down how to get these set up before I get going flying too far ahead here. Okay. So next we hit up number 5. Table shows the result of a poll of 150 randomly selected middle school students who are asked if they take French or Spanish. So again, do a little adding here, just in case. Always be ready in my rows and columns. Oops, I forgot how to add. That would have been kind of embarrassing if I... That's better. So I look at letter A. And you're like, well, wait a minute, there's no slash this time. It just says, probability, a 7th grader who takes French. Okay. So, how many 7th graders take French? But since there's no slash, it's just out of everybody. And there's 150 students that were surveyed. So if that slash isn't there, it's the grand total that we're using for our value on the bottom before we reduce it. That's not compound, okay? It's just a single event. But the next one goes back to having the dash. So here, probability of Spanish over the probability of Spanish and an 8th grader. If you can get the verbalized part like that written out, the rest of it should be easy. I'm just pulling them from places. So Spanish, got 68. Probability of Spanish in the 8th grade is 33. I'm trying to see if that goes down. Nope, that doesn't. And then I can work that way. But again, don't get sucked in, because now here on letter C, it's the exact same thing that happened with the boy and girl on the front. Don't think French goes on the bottom. Because here, the part after the slash is 6th grader. And again, top, 6th grader takes French. I don't have to write out everything, as long as I understand what I'm getting at here. And I go to my chart. 6th graders, 42, that's why I add all these up. 6th grader French is 19. And I kind of start to see how this is working. I'm like, okay, all right. So on letter D then, and again, we're looking for verbiage here, not numbers. What's going to go on the bottom of my fraction in letter D? I heard it. French. French is last. French is the second thing there. It's after my slash mark. Then up top, we're looking for a French and a 7th grader together. So French, take our total. French and 7th grade. We take that one that has both. You're like, okay, this stuff might not be too terrible here. So let me do, so we got one more box to play with here. So since they didn't tell me the grand total like they did in number 5, I just went ahead and added it myself. And if you do your math right, your column and your row should add up to the same thing. So if they ever don't, it means something didn't quite go right. So similarly to what we did in number 5, I noticed in this first one, no slash. A junior that did not attend prom. So junior, no, 56. Out of the grand total, there's no narrowing this down. And I figured out there's 200 total. So that would be my fraction. And again, if I do my math, enter, that's better, but it's not perfect. You're still showing me what you know if you get the 56 over 200. All right, let's do one more in this section, because I think you're probably getting the hang of it at this point. You're tired of me running my yibber. All right, what's going to go down below for letter B? Senior. And up top, we've got a senior that didn't go. So seniors, 116. Senior, no, 19. Just read carefully, and you'll be fine with that. Now, the one last twist, and we don't do a lot of this, but I did want to introduce you to it. It works similarly to the way that the boxes work. It's just a little different that we're going to work on. It's what's called a frequency. And basically, all it's going to do is take all of our numbers and turn everything into decimals, percentages. So I'm still going to add up my rows and my columns here. I'm just looking for a sec. Holy cow, Harty. This is going to be one of those times that I look back later and go, wow. 16, 12, and 2 add up to 28. Yep. I'm going to pay attention to this guy. So we've got 160 total. So when we go to make a frequency, basically what I'm going to do is I'm going to go to my calculator, and I'm going to take each number inside and divide it by this number. So like for instance here I'm going to do 16 divided by 160. And whatever that value is going to go in that corresponding box. So here like it's 12 divided by 160. And I put that number in. 2 divided by 160. So you'll notice there's only 6 boxes here. Like there's a lot more than 6 boxes over here. These boxes right here are the ones that I'm seeing over on this side. So that's what I'm filling in right now. And it's just, again, taking the number in the box, dividing it by the total. So 52 divided by 160. 60 divided by 160. And 18 divided by 160. So those divided by 160 get me these. And then to get the totals, I just add my rows. And add my columns. And again, I'm assuming I'm letting the calculator do this for me. And what should happen if you do it right is that my column and my row, if I add them down and add them across, should equal 1. Because it takes care of 100% of the people that are on the plane in this case. So divide to get this, add to get those numbers on the outside. But then it all works the same way. So I'm looking and I'm like, okay, so the probability that a coach class passenger did not check any bags. Coach class, 0 bags. 0.1125. Because again, there were no slashes there, so I just had to find the value in the column. Now you're like, well, would it be wrong if I'd have put, the fraction version of that? No. You'd have been okay still. But that's what we're doing. Probability, a first class passenger, so my first column, to check at least one bag. Ooh. At least one. Which could be 1 or 2. So I have to go first class. I have to add 1 and 2 together. So read carefully. You may have multiple boxes even to deal with. That can be a little bit of a challenge. But then the last 2 are going to look like what we're used to. Probability of coach class given, they checked 1 bag. All right. 1 bag. 1 bag coach, because it would be both. After the slash bottom, both go on top. So I'm like, all right, 1 bag total. 1 bag coach. And I'm still going to let the calculator, do all of my calculating. Once I get those, I type in 0.375 divided by 0.45. Normally, we're just going to go to a couple of decimal places. If you want to go further, you can, but that's really typically the only part we go. And then finally, after the slash, it's my denominator, top, first class, 2 bags. And again, we're just going to use the values from the chart. So first class, down to the total. First class, 2 bags. and divide that out. So again, it's just kind of getting used to the language that it has. And as you can see, we're going to hit this up again. I think I might flip-flop Tuesday and Wednesday here, but we'll see. And then your job with this is going to be to deal with the worksheet. But again, look for the ones, if there's X's, those are the card problems. Those are the ones you get to skip. But everything else you're fully capable of knocking out at this point.